This conference will now be recorded.
Yeah. Srinivas, you can post it here.
I've posted my code,
Okay, that's
Sandeep.
fine.
Actually, this was
Sure.
the logic for first missing positive integer. Uh, so I've tried the logic
Okay.
which you have sent me in the group chat, but it is failing for one particular scenario. And I'm unable to come up with a generic solution where it works for
Okay.
everything.
Okay. I see. So,
Did you get my
so
code?
this is your code for the missing number.
First missing number. I mean positive missing number.
Yeah, this one, right? Mm-hmm.
Sandeep, I'm unable to see your screen, I
Yeah.
think.
And you saw that zero is not counted, right?
Sandeep, I'm unable to see your screen actually.
Okay,
You
you're
are
unable
sharing
to
something.
see the screen, though I shared my screen anyways. Just a moment, I'll start again.
Okay.
Are you able to see now? So what do you
Yes.
see right now on your chat window?
Uh,
Sorry, on your, you see my screen
be,
or not?
being 0.java, right? Yes, I'm able to see now. Yes.
This conference will now be recorded.
Yeah, so first missing positive number. So the approach that you are taking is mainly utilize the same array as a map, right?
Yes.
Yeah, so you're saying
Uh,
if array size is 1 and if at 0 it is not 1, you will return 1.
I mean, that is the base case where I can straight away return an integer without iterating.
Okay, but if at get of 0 it is 0, then what will you return?
It is still 1 because they asked for first positive number.
Yeah, so you're saying if it is not 1, then return 1.
Yes.
And if it is 1, you ideally go and return 2.
Yes. Yeah.
Okay, sure. Yeah, so this first case you have handled.
Yeah.
Then what you are doing, you are starting from 0th index, going to array size, and what you are doing is you are checking if get of I is greater than equal to 0. Yes, number should be positive, and get of I is not equal to I.
Meaning I'm trying to adjust the position. Let's say at the 0th index, I found a number 3. Now what
Okay,
I'm doing is I'm taking this 3 and putting in the third position.
okay. So you are swapping basically.
Yes, swapping. And whenever I come across 0, when I'm iterating through going forward, then I'll swap those positions. And if I don't found that number, I'm setting it to -1. Am I not clear? Hello?
If the array is, if I give you an array where the,
Sandeep, you're not audible, Sandeep.
yeah, in between it lost the connection, but now you are able to hear?
Yes, it's clear now.
Yeah. I'm saying, but if array has elements 1, 2, 3, 4, because it is saying array will have elements like this, right?
Yes.
Then what will happen if 4 was in the first position and 1 was in the last position? What will happen then? In your
So
code, if I see, you're saying you're having this logic, but for 4, what will you do for first index?
for 4, the first index, I'm putting it to 0 because in the first, can you go to the screen once where you have the array?
Yeah.
So here we have 4, right? Now I'll check for
Mm-hmm.
4. Let's say if the 4 is not within the range of this matrix, sorry, range of this array, then I'm
Uh-huh.
making that index to -1.
Where are
Actually,
you
my
making that? Where are
here
you making that -1? No, that is
in the
inside this chain.
yeah,
So, okay, because that index is not equal to
it's
I.
not
So what you are doing else, you are making it -1. So
yes,
-4
yeah,
will be 4 will become
Yeah.
-1.
Yeah. Here actually,
Okay.
before setting the value, my intention is first I will iterate to the size of the array of n,
Okay.
and I'll check
Sure.
whether I found all the elements at their respective positions. So if so, at the end of the point, and if I could find all the positions, then my missing number would be +1, right? So that was
Correct.
my initial thought to write this code.
Okay. Okay. So you are going, if your number is greater than equal to 0, even if it is equal to 0, then what you are
Yes,
doing is you are getting at that index, you are getting the value if that is less than size. So what you are doing is you are swapping these two
yes,
values
yes.
at I and at get of I.
Yeah.
But
And I'm checking.
what is
I
this
mean, both
set? A dot set? Okay.
that would be.
That is
I
the
mean,
index and this is the value.
both would be the
Correct.
same, so I've set both of them.
Okay. Sure. So when you go with J1, if get of J is equal to J, this is the end where you are finding the missing number, right?
Yes, yes, yes.
Okay. And what is this if missing integer is 0?
What I thought is, let's say if there are two, if the size of the array is two, and if in my second position, if I come across zero, it's just a
Mm-hmm.
boundary case which will never happen actually. I'm always initializing my missing number to one at the
Mm-hmm.
at line number 10.
But if your array has only 1 and 2, what will be your answer?
If my array has one and two, then it would be two because I'm
Why 2
skipping the
is not the
first.
missing number? Why 2 is missing number? 2 is already there, no?
Yes, Sandeep. Actually, this is the only scenario where I'm not able to figure out. I mean, if the array have numbers from 1 to 10, so that is the only case
Correct.
which is not working. And for the rest of the cases, when
Okay.
I've tested, I was able to
Okay.
get the output with the current logic. Here, why
I
I
see.
have
So
kept
if
not
all, go ahead, go ahead.
in the line number 25, why I have kept not equal to 0 is because I'm iterating through from the first index. And if I see an
Mm-hmm.
integer, let's say I'm at the third index and I
Correct.
have number 3 at my 0th position. Now my
Mm-hmm.
missing number would be 4. I mean, this is
Correct.
one more condition where I've took because I've skipped iterating through 0th index. That's all.
But when you went ahead, see, after the modification, your array will anyways come in a state where it will have numbers filled as 0, 1, 2, right? At every index. In this array also, what will happen ideally in your case, at 0 index, what will you have? If the array has only 1 and 2, what is your approach suggesting to do?
So let's
If
say
we
if
take
I
a look
have
at your approach,
yeah,
if you have 1 and 2, let's see. So you are
okay,
starting here, right?
okay,
You are
yes,
looking value at 0th index. This value is greater than equal to 0, yes, and it is not equal to its index. So you are checking
swapping
if you're swapping it with first index value, right? With
first
this.
index. Now, yes, now the 2 would be in, yeah, this one.
Okay.
And in the next iteration it would happen and it would check that a dot get of I equal to a, and nothing would happen in that iteration, so end of the loop.
Okay. I see.
I'm not sure whether I've written a optimistic logic, but uh,
Now this
um,
problem has these tricky test cases. So ideally, like uh, there is a small twist. I'm just thinking like, how do we make it work? There is a small twist if you would have done. You would have got mostly things working in proper order.
you can ignore that line number 30 something because I was trying to test something and
Okay.
check whether
Okay. Okay.
that missing integer equal to 0 will never happen actually.
I see. Sure. So, but if we make a small change, let's say to strategy, so that you don't hit this particular case, right? Let's say 1, 5, 7, 2, 4. So let's say this is your array. Let's fill 0 also because 0 makes this very interesting. So rather than putting 0 here,
I think
let me put 0, right? So Srinivas, you know that if this array is 0, 1, 2, 3, 4, 5, like if this array is of size 6,
6.
correct? You may
Okay.
see the value 6 also, you may see value 7, 8, 9 also, but you know, like if the array size is 6, you are tracking 1 to 6 values. Is that correct or not?
Yes, Sandeep. Yes.
And your answer is guaranteed to be there in this
Yes.
range, or
Yes. 6
probably
plus.
it will be 7, or probably it will be 7. In 1 to 7 you will find the answer. Can I say that?
Yes. Yes.
Yeah. So what we try to do is we try to rearrange only these keys in the array range. So what trick we play is, right now what we are doing is we are dealing with 1 to 6 as indices in the array, right?
I'm
But
also
interesting
iterating.
would,
Yeah.
yeah,
Sorry.
yeah, go ahead.
Actually, I'm
No, no, go
iterating.
ahead.
I'm actually iterating from the first index. I mean, 0th index,
Correct.
and trying to adjust the values. But once I finish rearranging all the elements, and when I start iterating from when I start iterating in the array, I'm starting from first index
Right.
because I don't want 0th index. And if at any time I see a value which is same as the 0th index, I'm just incrementing it. That's all.
Correct. So your code is missing out this boundary case. Reason you are missing out of this boundary case is 6, 7, right? If either 6 is missing or 7 is missing, you are not able to differentiate between them,
Yeah. Yes.
right? So ideally, what if we try to map our keys from 1 to 6 only? You know, array is of size 6. Your keys are from 0 to 5, right?
Yes.
So we make a change like this, that rather than finding 5 at 5th index, we will search 5 at 4th index, one less than that. Won't that be
Oh,
better? Because that way we can accommodate 6 also.
okay.
Right? And what we do is we ignore 0. Let 0 be at its place. We don't care about 0. And we
Okay.
don't care about any value which is greater than n. Greater than or equal, equal to n we care, but greater than value we don't care. So we care about 1 to 6, how we map them into the array. This is a slight change in your strategy, and just see with that what benefit we will see.
Okay.
So when we see 1, we decrement it by 1 by checking that it should not be 0 and it should not be greater than n, correct? But n we are
Yes.
accounting for.
Yes.
So where will we swap 1?
In my first loop, I think I should be putting 1 at the same index 0 as per your.
Correct, correct. So this is, and this problem had array list only, right?
Yes.
So
Yes,
let's
I really.
say if the value is greater than 0, only then we care, right? And we change it to, let's say we calculate the index also. And how did I say we will calculate index? A dot get of I, we will subtract 1 from it, just so that it is more readable for understanding right now,
Okay.
correct?
Okay.
So current element is giving us the index. Now you say if element at that index is not equal to the current element. So what was this check that you were doing? Okay. I is not equal to element at that index. Can we say that? Is this fair?
Yes.
Then what we do, we go ahead and whatever way you are swapping, we are doing the swap. But this time you will do the swap if a dot get of I. So a dot get of I has, we have changed
Sandeep,
it to our index.
sorry to interrupt. So if my IDX is a dot get off I minus 1,
Hmm.
uh,
We will do this
okay.
calculation also inside.
Okay.
Now it will be safe, right? You're worrying about that being -1 for 0, right?
No, no, I got it. So which means we are actually looking the element 5 in fourth position, right?
Correct. That's correct.
Okay.
That's what we talked about, right?
Yes. Yes.
Benefit
Yes.
of doing that is that you are able to keep track of 6 also, and
Yes.
that's the thing we want to achieve, because we don't want to miss 1 to 6. Because if in this array 1 to 6 are present, it will be very easy for you to find out which number is missing. Correct.
Okay. Yeah.
So we are taking care of only these numbers. That's what our focus is right now. Correct.
Okay.
So going back here, so what we do, if this value is greater than 0, we care about it. And I
I
also
think
put a check here. And this
okay.
value is less than equal to, only then we care about it. Otherwise, we don't care.
Okay. Okay.
Now we will be
Understood.
keeping track of 1 and 6, right?
Yes.
So now when we get that value at that index I, the position, the index that we get is IDX. So this index will help us map it properly. And can I say, like, I can go and swap this value directly? Okay, let me see. You are swapping if IDX is less than a dot size, which is fair to do that. If this is less than a dot size, only then we go and do the swap, correct?
Yes.
So you are taking in temp, and this time you will be taking the value at that index, and you will be setting the value at that index IDX with
IDX.
get of I and a dot set of I to temp. This is fair. Now, according to our new change, this should be good.
At IDX, okay.
See, you took the
So
value from that IDX. In
yes.
IDX, you are putting current value, and in current value, you are putting temp. So this is the swap that you are doing.
Okay.
Right? Now,
Yes.
there will be never a case where our IDX is not less than a of size. Can I say that? Now this condition, this if condition that we are writing, ideally it will never be false. So we will never get into the else case. Can I say that?
Yes.
Yeah. So now the thing is, this is what we are doing, and let's see whether this approach will lead us to the correct answer or not. So we try to trace our code with the same array that we are seeing. When you see 1, for 1 the position you will check will be 0, 1 will be swapped at 0, so it remains the same. Can I say that?
Yes.
For 1 the position calculated is index calculated is 0.
0. Yeah.
For 5 the index calculated for 5
4.
is 4. You go and take a look at 4, and you see if index 4 it is not 5. Ideally we can also check if that index does not have 5, we will go and swap, because duplicates can also happen. But for now we go and swap it. So 4 comes here and 5
5.
goes
There.
here, right?
Okay.
Now one more challenge is we brought 4 here, right?
Yes.
We should also pay attention to this 4,
Yes.
because we should not ignore examining it. Now it is 4, so we should go to index 3. This 4 should also reach at 3. Can I say that?
Uh,
Ideally, we should not be moving ahead by ignoring this 4,
yes.
because otherwise this
Yes.
4 will never reach its correct position, and in the end we may hit an issue.
Yes.
Earlier you
Yes.
were trying to take care of this 4 case with -1. So what if I do one thing? If I have swapped something here, I do not increment my I, so that I again compare for this. So
Okay.
here ideally, if you see, we are incrementing I always,
Yes.
but we should increment I only if we are not doing a swap. So ideally, if I don't want to remove it, can I say if I do a swap, I will do I minus minus? This is fair.
Okay.
So after swapping, we are decrementing it so that we compare again from the same index,
Okay. Understood.
right?
Yeah.
Okay. Now, if we go ahead like this, one challenge may come is typically when we do this kind of thing, increment is happening outside, decrement is every time if it gets in this loop. For that, it goes inside, it does the swap. We have to avoid that. You know what I'm doubting, what I'm
Okay.
saying is, here we are doing I++ after every iteration, right?
Yes.
If inside this iteration we come and if we are doing a swap, imagine if this situation would have been like, if here we had let's say if here we had 5, right? And here also we had 5, then what will happen?
Okay.
If both places were 5 and 5, what will happen?
So it would look for the fourth index and it would get the same, number. So which means again, it would be stuck in the first I equal to 1.
It will keep swapping them, right?
Yes.
So we can avoid that situation by saying here and a dot get of idx is not equal to
I.
a dot get of I. So this way we avoid, right? So that we do not get stuck over there.
Yeah. Okay.
So now you think about it, this, whatever we have written, what will be the result of that? End output, end array, what will it become? What will happen if 0 comes? If anywhere we encounter 0, what will happen?
We are not checking that. And
We are not checking that, but we
yeah.
still have to think of what will happen if 0 comes. Let's say there is 5, there is 0, there is 9, there is 1, there is 3. So we should be clear with our approach. So when we look at 5, 0, 1, 2, 3, 4, where will 5 go?
In fourth index. So 3 and
And
5.
fourth index value will come here, correct?
Yeah.
Sorry, 5 will go here. Now we
Yeah.
look at this 3 and we say that your index is 2. We look at 2 and we say 3 should ideally go at index 2. So what we do, we cut it, we bring 3 here, correct?
Yeah.
Now we look at 9. Where should 9 go?
It's out of the range, so
It's out of the range. So what are we doing?
incrementing it.
Yeah, we are incrementing. So now we say let 9 be here. Let's go to this index. Now what is here?
0.
0. So what do we do with 0?
So IDX of 0 would be -1. Out of bound. Because 0
No,
of
if you
-1
see,
would
we
be.
have checked here. We have checked here. We don't care for 0.
Okay. Okay.
So let 0 be 0, correct? So we
Yes.
don't care. So now we come to this. Compare this, you get 3. 3 minus 1 is 2. And we get into this situation that current index 2 and current value is 2. So they are same, so we don't swap, correct?
Yes.
So we come here. Now look at this 1. What should we do with this 1? Subtract 1 from it, get its position. Its position is 0.
Yeah.
So at 0 index, we check the value at 0 index is 9. So we are checking our index is valid within the range, and the value, current value 1, and at that index value is 9. They are not the same. So we should go and do a swap. So 1 comes here, 9 comes here, right?
Yes.
And since we have done a swap, we take a look at 9 once again, because whenever we do a swap, we start from the same index. Now look at 9. 9 minus 1, 8. Sorry, 9, it is there. So 9 is out of range, right? That value is
Yeah.
not less than equal to array size. So we say ignore it, move ahead and come here, right? So when you come here, what do you get? You get
5.
value 5. 5 is already at its current index. When it is already at current index, we don't swap, don't do anything. We go out of the bounds of array, right?
Yes.
Now your final array is looking like 1 is there in the first position,
1,
0,
3,
3, and here we got
9,
9, here we
and
got
5.
5. Now if you look at this array, can you tell the missing number?
2.
And that means now this logic also needs to change, correct?
Yes.
Because now if you see with this approach, what we try to do is we did not miss any number, fitting it
Okay.
into array. If it is a valid range, we are keeping it in the array. So that way we are making sure that we don't miss it. So can I say here, we'll say for I0, I less than n, or a dot size, I plus plus, and we will say what? If I plus 1 current index plus 1 is equal to a dot get of I. If this is not equal, what should we do?
Uh, y is I plus 1, 2. Okay, got it.
You tell me
Sorry.
how.
Yeah, got it.
Yeah. So
Yeah,
what should we
understood.
return? What should be the missing number?
It should be I plus 1.
Awesome. Yes, it should be I plus 1, right?
Yes.
And if this loop has completed and you did not find anything, then what should be the answer here?
Uh, it would be 6. I mean, if the size of the array is 5.
Correct?
Yes.
Okay. Now think about this. Will this case be handled already by the logic we have written or not?
Yes.
If there was only one number and that number is 1,
Okay.
you would have tried to map that 1 to index 0. It is already there. Don't swap. Run this loop, find the answer. Correct?
Yes.
And if it was 2, will this logic still work without the first if condition?
Yes.
Okay. And if it was 0,
I think, Sandeep, in the previous case where we have only 2,
mhm.
so we are not swapping it.
Yeah, so we are leaving 2, right?
Yes.
When you run this loop, you will not find any value. You will return.
Yes. Okay. Okay. It would execute the line number 21, 29. Yeah, got it.
Oh, but if it exits, yeah, here it will execute, right? It will say
Yeah.
1 is not
Yes.
found. Yeah,
Yes.
so this will work. So for 0, because 0 was another good case. If it was only 0, what will it do? 0 will be ignored.
Yes. And plus 1. And it would return dot size plus 1. A of A dot size plus 1.
Pakka, how will it return a dot size plus 1? If it is only 0 element, won't
Yes.
it hit this
So,
case?
because I plus 1 is not, I plus 1 is 1, right? And 1 not equal to
If 1 not equal
1.
to this, then what are we returning?
0 plus 1. Yes, it is still okay.
Yeah, so ideally, can we say like this logic that we have thought will work, and reason this logic will work is because we have also accounted for the accommodating all the values that we have. So yours was Java code, right?
Yes.
Let's just give it a try so that we can validate our thinking also. So all these questions that you saw like in array, they were utilizing a fact that you can use that array as a map, right?
Yes.
Yeah. So and yeah, all these questions that we are doing, and every question has like little learning involved in that. And yeah, so if you see now we have kind of taken care of all the cases with this. Ideally, even if we would have put your first case, this would have been additional caution, even that would have worked, right? And ideally, this was taking care of one particular case that was working fine. Yeah, so this question had these tricky cases. If you miss out like the accommodating the last value, then it's a problem.
Sandeep, can you paste the code in the chat so that I'll try writing the code, but if I miss something, maybe you'll have it for reference.
Okay, you can refer to it. Sure, I'll do that. Yeah. But you understood like where you were stuck and why
Yeah.
it was not getting to the correct point.
Yeah. Actually, the mistake I've done is I've read the different inputs and outputs and then started generating the logic. So
Okay.
that is a little incorrect. Or I think that is a place where I actually went wrong.
Yeah. So key learning that you can take away from this problem is if any time you have to map the entries to an array, make sure the values that you care about they are part of your set. They are considered every value.
Okay.
right? That's the reason, like a zero-based array and one-based array, both are kind of given as a question, because many a times if you start giving people one-based array, people do make this mistake of not mapping every value to the proper index.
Yes.
Because what you are trying to do, you are trying to fit every value at its corresponding index, because by intuition it seems like that is the correct way of doing, so that we don't have the hassle of adding one or subtracting one,
Yes.
right?
Okay.
Yeah, so this was your first doubt, first question. Anything else, any other question you have?
No, sir. I mean, I got stuck solving this. So,
Okay, sure.
and
And
I think I mean, it is taking a lot of time for me to solve problems in
mhm.
interview. Yes.
Yeah, which is fine, Srinivas, these questions are inherently hard, they are not straightforward questions. So but if you want to keep your bar high, it's good to solve these problems even if it takes time, because you see a lot of concepts are implicitly gained by doing these problems.
Yes. And one more, I mean, see, in this problem, the mistake what I've done is I did not put the value in the right place. I mean, in the exact index. So
Correct.
actually, what's happening is when I'm working on some other problems, uh,
Mm-hmm.
when I start writing some logic, uh, and if I come across test cases where this logic is not fitting in,
Mm-hmm.
I'm unable to I'm unable to come up with a proper approach or proper logic where I mean the th see here you have a thought where you have to put the number at the index place, right? So things
Mm-hmm.
like that.
Yeah,
Actually, I'm lagging in those things. I'm not sure whether it would be coming with practice or
it will come with the
from
practice, Srinivas. It's like when you do a problem of this kind, ideally, because now what you are trying to master, think about it, like reaching from 0 to 70% is easy. Do you agree with that?
yes, yes,
But reaching from 70 to 90, it is time taking. It becomes a little hard, because that is where more effort, more practice has to come into picture. If I ask you to solve this problem without putting these constraints of
yes,
constant space, can you do this problem without any extra constraints?
yes.
How will you
I
do
can,
this?
yeah. First, I thought of using a set or a map. First,
Correct.
I'll take a set and I'll start adding numbers into the set. I mean,
Correct.
so when I iterate the set, I will be getting the least positive number what I want.
Yeah. So basically, if
But
your array had 10 elements, for 1 to 10, you will search what is there in the set and what is not, right?
yes,
So without constant space, you can easily do it. Can I say that?
yes.
What will be the time complexity of your approach?
O of n plus O of n. I mean, if you consider searching in a set is O of one, then
Yes,
the time complexity would be still O of one. O of n, sorry.
it'll of n, right?
Yeah. Yes.
Yeah. So it's just that you are using extra space. Now think about the person who begins programming. Will he be able to think of set approach easily if he has not done any set problems or anything like that, right? Will he be able to come up with of n solution directly?
Uh, no.
How come you are able to come up with that?
Because I'm aware of set data structure or how to use.
Exactly. Exactly. So that is how things work. Now you thought of a set data structure, and if I say get rid of that set, you still want to achieve. If I say don't use set, and imagine you are not even aware of this map approach, can you think of any other approach?
Uh,
We say time complexity. If you achieve even worse, that is fine, but you should not be using any additional data structure. Even if you take a little more time, that is fine.
yeah.
Any other approach that comes to your mind?
Yes, I'm thinking actually. So I can I can run a loop inside a loop where I will search for the elements.
Okay. So you will first search for 1, then search for
Yes,
2, then search
yes,
for
and search
3.
for 3 and search for whatever you have done in O of n. Now I can do it
Now it
in
becomes
n square. N square.
n square, you know. Can you do something better than n square, step by step approach? What is better than n square?
N log n.
Can you do it in n log n?
I can do a binary search where
But
I'll
array is not
have.
sorted.
Okay.
It says it is unsorted.
Yes.
And ideally, if you do binary search, it becomes log n, not n log n. Binary
I
search
can have
is
I can have 2 pointers where no, sorry.
see there are 2 hints available in front of you. One it says unsorted, one is n log n. Can you sort the array and solve it? If array was sorted,
Okay. Yes.
if array was sorted, you could
And
have done in
the binary approach.
why binary approach? If array is sorted, even if the elements are -7, -6, -5, 0, 1, 5, 9, how will you do binary search?
No, what I mean is, I mean, once I sort the array, I needed to do the binary search.
You
So
need
I
to
will,
do
let's,
binary search or
no, not required. So if this is the array, then I'll start looking for the least positive integer. Or
exactly.
let's say,
So after that, a linear search is good enough, right?
yes.
Okay, so n square is a brute force approach. N log n, you are saying if somebody allows you to sort. If we say optimize it further, you say I will use a set data structure and I can do it in n. Now this problem, if you see, it has come to an extreme level where it says I'm neither allowed to sort, nor allowed brute force, or nor allowed to use set. So what do you do now? So using set, what you were doing is your check was faster. Then I was able to check, you were able to check that it is there or not there. Right? That's where you said, hey, can I use array as a set? Imagine the set you are using rather than set. If you would have used another array as count arrays, use set as a concept. So if I give you another array of size n or n plus 1, this array has one 0th index which you don't care about, 1 to other indexes if you care about. If set is not allowed, but you can take another array, can you manage with that? Initially make all the elements false, right?
Yes. And
Now
whenever I
loop
come across an element, I can make it true.
perfect. So you are saying whenever you come across that element, you will make it true,
Make
correct?
it true. And my
And
first
eventually
false would be the missing
missing element,
integer.
right? So if I say this array, the count array that you have taken, don't take it n plus 1 size, take it n size only.
Now
Then,
I'll make the uh, I minus 1 index to
mhm,
false.
right? So you will
Sorry,
make,
true.
you will start using this also. And for
Yes.
one, you will make this true. For two, you will make this
Yes.
true so that you don't have to take one extra space. This is correct.
Yes.
Now we say you are able to come up with an approach where you can do this problem with an array of size n. We say, can you get rid of this array? Then we say that you say, hey, let me see, can I use the same array to serve this purpose that my count array was serving? And that's where what you did when you saw an element 1, you moved it to that location. That is like marking it true.
Okay.
Now you see how we have taken a step-by-step journey to reach here.
Okay. I think the point where I see the problem where I should use a constant space and OF and time complexity. I think I should start thinking in from n square to the I think step by step. Maybe that would help me to uh, reach to some optimistic solution.
Right. And takeaway wise, if you look at many problems, we'll say we will cover two more problems in this category where we say like if somebody pushes you, don't use extra space. then you have to see how can I use the space that I have to serve that purpose. And array, best way is don't treat array as an array. Treat array as set or as a map. It is array is a map with the keys fixed. Can I say that array is a map with keys fixed?
Yes, where index is the
So
key
if you,
and okay, understood.
that's right. So array is your set, array is your map. Ideally, when we say I will take a set and do it, you should also think that in place of set, I could have used array also. And if that is the array that you are going to use, can you achieve the same effect using the current array? Right. So this is second problem like this that we have seen. I think there was one more problem somebody asked. It was from this category only. I forgot. Like last time somebody asked this similar question where again array was used as a map, but in a twisted format. But yeah, this is your learning. So keep this learning in mind, because when typically most of the companies will not push you to this limit, but when the pay package of a company increases, that's where the constraints also start increasing. That give me in constant space, give me in best possible time complexity, and that is what we should strive for. And gradually we reach those solutions.
Yeah, understood.
Yeah, sure. So any more questions, any more things? I mean, did you try graph problems also?
No, Sandeep, I'm working on interview bit problems. I have to start working on it tomorrow.
Sure, sure, no problem. Like if you are working on these problem anyways, I think here when you reach graph section, you will see some of those problems coming once again. Do we have, yeah, largest distance between nodes of a tree, level order is there, which is VFS, stepping numbers is there, which is jumping numbers, word search board, this is what I have added. Similar problem to this is added to mentor pick. So anyways, if you are doing these problems, this will cover that, but make sure like VFS, DFS and topological sort are something which you are comfortable writing, even if you write
Yeah.
uh, in just an
Sandeep,
ID.
actually, in Sunday's class, you have explained the topological sort, right?
Right.
Uh, actually, what I feel is it's not into where we can think of that logic what you have uh, explained. So, is that how we need to learn that approach, or how to get? I mean, how to think in that direction?
Okay, so what I was explaining there, if I have to summarize once again, graph problems, when you look at the problem statement, you somehow have to figure out that this problem has some correlation between entities. Two things I talked about. Wherever you see relationship, we can say it's a graph problem. Later on, it can become tree problem also. But relationship is something for graph. And wherever relationship has a dependency, that is where we say topological sort is applicable. Right? So anyway,
Yes.
since you are only there, let's see. Let's open lead code and look at some of the problems of topological sort and just see like whatever two concepts that I was explaining, that first you have to understand this is a relationship problem where two entities are correlated in some way, and then there is a dependency. So this way we can see whether this pattern gets applied, and if you get more examples, it will be more clearer. So here if I go to topological sort, at least there are 5 problems given here, right? So alien dictionary is what we discussed there. Remember what
Yes.
I
Yes. Yes.
covered in the class? Let's take a look at all 5 so we will get a clear understanding and idea about topological sort, right?
Yeah.
So course schedule is what the problem is. It says there are total n courses you have to take. They are labeled from 0 to n minus 1. Some courses may have prerequisites. For example, take course 0. To take course 0, you have to take course 1, which is expressed as a pair.
Yeah.
That Before 0, you have to take 1. Given total number of courses and a list of prerequisites pairs, is it possible for you to finish all courses? Now, when you look at this problem, nowhere it is mentioning it is a graph problem. Correct?
Yes.
It says there are n courses. Courses have prerequisites. Course 0, you have to take course 1. So looking at this problem statement, out of the pattern we described, what is it that you are observing that should take us in that direction?
Sorry, can you come again? What was your question?
So
At
question
last.
is, I'm saying when you look at this problem, what is the takeaway from this problem from you? If you have to identify.
So by problem statement, I could see that there is a dependency on the output, or
Absolutely.
uh,
So you are saying there is a dependency. So ideally you are saying in order to take 0, you should take course 1. There are 2 courses to take. To take course 1, if you have to take 1, before 1, you should complete, you should have
zero.
finished course 0. Then only you can do 1. Now, second problem, a second example, if you read, it says to complete 1, there are 2 courses. In order to complete 1, you have to complete 0. In order to complete 0, you have to complete 1.
Which means it's a cycle.
Yeah. So it is impossible. So you have to tell it is possible or it is not possible.
Okay.
It's a cycle detection problem on graph. You detected there is a dependency. You see there is a relationship between two things and it's a directed relationship.
Can
Is
we
it
also
helping?
do this using linked list or?
So if you do it using linked list, now think about this. In order to complete course 1, course 2, course 3.
Okay, what if there are
If
3 prerequisites? Oh, I'm sorry. Yeah.
absolutely. Yeah. So if there is one relationship, yes, you say it is my link. If I can try to make it as a linked list also. Yeah, those are special cases for this where you can say relationship is not only this. You can say linked list also maintains the relationship, right? But here we
Yes.
see the both the patterns were there. Relationship was there. Dependency was there.
Yes. Okay.
So if you try to do a topological sort on this, your topological sort will not print all the nodes of the graph. You will say there is a cycle. That is where we were talking about that topological sort is also used for cycle detection.
Yes.
Right? This is one problem. So it gives you a little idea. Let's look at second problem. Okay, it's just a small twist over the first problem. Previous was just telling it is possible or not. In this problem, what does it say? There may be multiple correct orders. You just need to give one order in which you should complete. If it is impossible, return an empty array. So now it is saying, give me the order in which you should complete. And it says, give any order. So what is this problem?
Just one. It would be, I mean, where I can have more outgoing, where I can have multiple start points.
Yeah. So you can have more than one output also, right? But it says return
Yes.
any one of them.
Yeah.
So
So
if you
when I
have to
have
code this, if you have to code this problem, can we say any topological sort is correct answer?
yes, because topological
Can I say
sort,
this
when we
is
do, we can have multiple start points.
exactly?
Okay.
Can we say this is direct topological sort problem?
Yes.
Second. Third, alien dictionary is what we talked about.
Yes.
So here also let's apply and see like do these both these things hold good, relationship and dependency. Words are sorted lexicographically by the rules of language. Derive the order of letters in this language. Since you know this problem, ideally now I'll say like it is going to be obvious, but if you see they are sorted lexicographically, sorting doesn't tell, but lexicographical tell there is an order and we have to again give the order. And there is a relationship between these words. Ideally, even if it is sorted, there is a relationship. Right?
Yes. Yes.
Okay, let's look at this one. Longest increasing path in a matrix. Yeah. Given a matrix, find the length of longest increasing path. From each cell, you can either move to 4 directions.
So if I want to find the longest way, I should, it is, if we go for a depth first search approach, we'll be getting the longest path.
Yeah, using depth first search also you can solve this problem. That's correct. So ideally, if you start, but if you do depth first search, ideally you have to start from
9.
first vertex and find the longest path. Then second vertex, find the longest path. Third vertex, find the longest path. Because it can start anywhere, right? Ideally, 4, 8, 6, 9 could also have been a path. And it is increasing. So ideally, his answer he's giving is 1, 2, 6, 9 is the longest. But can I say 4, 8, 6, 9 is also an answer?
No, right, it should be the increasing.
Okay, 4, 6, 8, 9 is not, because diagonally we are not allowed to move. Correct?
Yeah, yeah.
So out of all you have to identify. So one thing is, like here I'll say one more pattern. When you are allowed to move in 4 directions or 8 directions in a matrix, it eventually becomes like a graph.
Yes.
From any node you can go to there, and then you see there is a cycle also that forms. 9 can go to this 9, this 9 can go to 4, 4 can go to 8, this, then you can come back also.
Yes.
Right. So I'll put third category also. Yes, there is a matrix with move in 4 or 8 directions. Can we say that is an indication of graph problem?
Yes.
Yeah. So now when you have to find longest increasing path, that means from first 9 that you see, its neighbors, if you take a look at, let's just try to model it. From 9 you can move only to first 9 to where?
9 if it's breadth first.
Yeah, but it says increasing path. 9 to 9 it will not be. No, not breadth first. I'm saying ideally if you would have started from 9, what are your possible moves so that you get increasing?
I should either move to my right or
9.
down.
Yeah, but
That
right,
is my
if you go to
feasible.
that is not increasing, down if you go that is not increasing, correct?
Yes.
Okay. Now how about the second 9? From there, do you have any possibility to move anywhere?
No.
Okay. From 4,
I have
how many?
1.
Why? From 4 to 8 also you can go, right?
I'm sorry, 4 to 8 and 4 to 9 too.
Correct. Now from 8,
0.
0. From 6, middle 6, the center 6.
2 directions. I mean 3 directions. Sorry, 2 directions. 6 to 9 and 6 to 8.
Okay. From the first 6,
1.
only
6
up,
to 9.
right?
Yeah.
Okay. Then let's come to the last row. 2. From 2,
6.
only the first 1, 6.
Yes. Okay.
From 1,
2 and 6.
yeah, 2 and the upper 6, center 6. And from last one,
And sorry, 8. 1 to 8.
8. Right. So this is a graph that we are forming. Ideally, what you said is like from every cell, if you try to do DFS and all, from every cell, if we try to do, we can find an answer, right? What is the DFS, the deepest DFS we can do for increasing, and what is the length of that? We can fill another matrix for every cell. What is the longest path we can go considering all the neighbors? That way we can do, correct?
Yes. So in depth first search, well, let's say when I start with 9.
When you start with 9, you have two choices, right or down. Your answer will be 1 plus max of those, right?
Okay. Okay. Understood. Yeah.
So that way, if you do from every cell, you will be doing DFS again and again. That will be non-optimized code if you do DFS from every cell. But if when you go from 9 to this 9, if this 9 knew its answer, then your answer would have been easier to find.
Yes.
Some sort of DP is also applicable, but somehow what we did, we just try to draw a graph, and in this graph we have to do we have to find the longest increasing path, right?
Yes.
And if you see the arrows, the way we have drawn arrows, they are always in dependency order because arrow is always from smaller value to higher value.
Yes.
If I do a topological sort of this graph, the length of topological sort will give me the longest path.
2, 3, 4. So sorry. So when we say topological sort, the first thing would be
You always
from.
start with the one which is not dip. So there are multiple topological sort. Ideally, you will see what is the longest topological sort that I have. 1 to 2 to
Okay.
6 to 9.
Okay. Yeah. Okay.
Then 1 to 6 to 8. That's
And
it.
1 to 8.
This is, and this 1 to 8. That's it. Out of these three topological sorts,
Okay.
no, from 4 also you can do. But fourth
Yes.
topological sort will
4.
end up here.
Yeah.
So find the topological sort length from all the vertices which are possible as start
Okay.
vertex and see how far you can reach. So that is what this problem is saying, that you could have applied topological sort also. So implicitly we have seen topological sort is also using DFS or BFS. So DFS solution anyways came to your mind.
Okay. Understood.
Yeah, but this, when we solve matrix problems, we don't have to make this graph. This was just for your understanding,
Yeah.
so that we can see it clearly.
Okay.
Correct?
Yes.
Yeah. So this is a third example. Fourth example also, if we see what is that problem statement. So it will actually do a coverage of problems of topological sort that are available. Check whether the original sequence can be uniquely constructed from the sequences in SEQS. Okay, this is SEQS, some sequence is given. The OR sequence is a permutation of integers from 1 to n. This is what you have to get. Okay. Construction means building the shortest common super sequence of the sequences in SEQS. Shortest sequence of all the sequences in this
Yes.
are subsequences of it. Determine whether there is only one sequence that can be constructed from this, or it is OR sequence. Okay, so problem is little convoluted.
Let me read that again, just a second.
Sure. So
Okay. Got it.
yeah. So what does it say? It says you are given few subsequences. First, you have to find a super sequence, which is super sequence of all of these, and then you have to tell whether that super sequence is equal to or not.
Yes.
Yeah. So how do we model this problem? Ideally, here the relationship is not evident. Pretty
Yes.
like it's not looking at the problem statement we can come up with. This is a graph problem. So ideally, if we have to solve this problem, we will go ahead and try to find out the super sequence of this. And super sequence is what? I mean, take a sequence out of it, 1, 2. What
1,
will be
2.
super sequence of 1, 2? Just look at only one sequence. What will be super sequence of 1, 2?
It is again 1, 2.
1, 2 only. Now, when you take a look at 1, 3, also, what is the super sequence which is super sequence of this as well as this?
Yes, it is 1 to 3. And 1, 3, 2, and 3, 2, 1.
Mm-hmm.
All these are, I think.
Yeah, all these are the correct thing. But what it is said is, even if imagine you say it is 1, 3, 2. No, okay. If it is super sequence, I believe the order should also be there. So if it is 1, 2, it is saying after 1 there is 2 because order is important, right?
Okay. Okay.
In 1, 3, that means after 1 only 3 should come.
Okay.
So we don't have any other, what do you say, relationship given from this sequence, correct?
Yes.
So what are the sequences possible from here?
Okay. 1, 2, and 3.
Or 1, 3, 2 also?
Yeah, 1, 3, 2 also.
Because between them there is no order given to us.
Yes.
Yeah. So now what does it say? Is not the only one sequence that can be reconstructed, because 132 is also valid sequence that can be reconstructed. So it said whether there is only one sequence that is possible, that means you draw a graph. If there is only one topological sort and that sort is equal to this, that is your answer.
Okay. Here the topological sort would be 2, right? 1 to 2 and 1 to 3.
1, 2, 3 and 1, 3, 2. Correct. There are two topological sort, and it said, is it possible to have only one super sequence? Right? And let's take a true example also. Here it says that you are given a sequence 1 to 2. Now, sequence have
1,
this relationship that 1 comes before 2, 1 comes
1,
before 3, sorry, 1 comes before 3, and 2 comes before 3.
Yes.
There is only one topological sort possible, and that is equal to the OR, so we say.
Okay.
So little, like, that's why they have given more examples. Little more going over the problem, we can see that because this is talking about super sequence, ideally if it was if it was just the array, no order guaranteed. If it was a subset problem, we know we could have done that subset problem with just using a set. Using a set,
Yes.
we could have added all these. Then out of this, all these we could have added. We could have added. Now, if this set has all the numbers of this OR, that means we say, yeah, we are able to form a set which is
Yes.
equal to OR. Then it is kind of an anagram problem,
Yeah.
right?
Yes. Yeah.
Yeah. So since it is a sequence, so this is the difference that we discussed, like subsequence, sub-array, and subset. You're clear about this, right?
Yes. Subarray is where the order should be preserved and
Order should be preserved and it should be contiguous also.
continuous as well. Yeah.
Yeah, so this is contiguous and order. This is
Subsequence where the order should be preserved and it need to be continuous.
correct. It doesn't need to be contiguous. And
Subset
subset,
would be, I mean, it did not to preserve the order because 1, 3 and 3, 1 both would be subsets, right?
right. 1, 3, 2 is a subset, 1, 2, 3 is a subset, 1, 3, 2 is also a subset. So order doesn't matter. 2, 1 and 1, 2 are same subset. So that's the difference. So ideally in subsequence, we see order was implicitly there. And that order helped us kind of see that if I have to maintain the order of these two, like 5 to 2 to 6 to 3, and then 4 to 1, 1 to 5, and then
Okay.
5 to 2. There is one sort possible. If we just pick them, put them in a map, like a graph of int and list of int, right? If we can build a map out of this, then our problem is solved. Can we say that?
Can you repeat? I mean, how did you solve using map?
I'm saying ideally when you are reading this order, one possibility is you read this order in insert in a linked list or insert in an array, right?
Yes.
But
Yes.
here since multiple things are there, first sequence, because he can give you multiple sequences also, right? 1 to 2,
Yes.
1 to 3. So ideally if you see 1 to 2, there is an order 1 to 3 is also there.
Okay. Okay. It
You will
would be
not be
in.
able to. So we say we build a map from 1 to 2 and 3. We build a map for 2 the children are 3. That's how we represent a graph, right? Whatever I was drawing earlier, I'm just saying that we can draw it like a map.
Yes.
And another thing it has said is, it says integers from 1 to n. So rather than taking a map, we can take an array also, like array of list,
Yes.
right? So then you have a list of integer and there is an array.
Yeah.
So at 1 you will store array of 1, at 2 you will store array of 2. So once you have constructed this question is about do a topological sort, and if there is a single topological sort that is coming, you just have to check if that topological sort is equal to org or not. If it is equal, you say yes, that is the answer.
Okay.
Right. So yeah, this is another problem of that category. See, these are, if you see the company name,
Okay.
right? So graph, topological sort, and similar questions we have seen course schedule. Yeah. So these are the 5 problems that we saw, like where if you know the concept, then only you can think about this. Otherwise, if people give a linked list based solution for ordering, then we know it is going to fail somewhere. The moment interviewer says that what if there are more than one relationship, that's where our mind should go in a direction. Hey, I can store it as a graph rather than linked list.
Yes.
Right. Yeah. So this is good that you raised this point. So we could see some pattern. Any other pattern where you struggle, you face problems?
No, sir. Currently, I'm solving problems on arrays, and I'm trying to, think of approaches.
Sure.
But I
Sure.
want
So
to give a try even before reaching to you. So
yes,
I
yes.
still have a lot of problems in my bucket, but I want to first try, and then I'm not able
Okay.
to, then I'll ping in the
Sure.
chat.
I will suggest one more thing, like in array, some problems are mix and match. If there is any other area where you feel little comfortable, like strings or 2 pointers, bitwise operators, linked list, stack queue, trees, backtracking, feel free to jump over, because what happens in
Okay.
every category, you will see easy problems also. I mean,
Okay.
if you generally go to trees, you see vertical order traversal of a binary tree.
Okay. Actually, what I
We
was
have done
thinking
that.
is when we
Yeah.
go, no, actually, what I was thinking is when we go to the next levels, when I jump to the next levels, the problems would be much more difficult, and I was not
No.
actually checking into those.
Okay. No, it is not like that. If you see minimum depth of a binary tree, sum of root to leaf numbers in a binary tree.
Okay, I think I've solved these problems in Metapic. We have these problems in
Exactly.
Metapic. Okay,
Exactly. That's the point I'm trying to tell you, that in
okay,
array are only array related problems. Same way, like the other areas you are comfortable with. If I take you to the linked list area or any other area that we have covered so far, if you see a linked list is palindrome or not, remove duplicates from
okay.
sorted linked list, merge to sorted linked list, remove nth node from the end. We have done nth node from the end
Yes,
finding, right? Here he's saying
yes.
just remove it, rotate it, reverse it, reverse in k chunks,
Okay.
add 2 numbers as a list. So list
Maybe I
cycle.
think once I solve these problems, I may get some confidence to move on. So I'm getting stuck
Yes,
in errors and
exactly. Because what they have done is, the problem is in array, they have put every category. It's like even array as a map, and a lot of algorithmic problems, like this was array as a map. This is another problem where you are using array of composite data types, and this is sorting related thing. So in array they have put every category. In fact, there are matrices also, rotate a
mm,
matrix, right? So if you see, like, feel free to jump over, because
okay.
you will gain more confidence when you attack those areas which you are comfortable with, and then you can always come back to array problems when the things
Yes.
are comfortable, right? So what we are going to cover in coming weekend, right? This weekend's class that we have, ideally, if you see, gradually we are covering various topics. So topics wise, now they will not look strange to you. What is binary search, strings, 2 pointers, bit manipulation, linked list, Stack and queues we introduced, but we will do some tricky problems on stack and queue. Backtracking we have done extensively. Hashing is something we will do in the last week. Tree and maps, heaps and maps. There are some problems in that category also that we will talk about. But key focus of this weekend that we will put on will be on greedy algorithms, and there is one more divide and conquer where they have not categorized separately, but we will do little discussion on divide and conquer greedy, and we will do some tricky interview questions on binary trees, because there are binary tree and heaps, because there are areas uh, where those kind of
Among,
tricky questions we have not discussed.
yeah, amongst all of them, I mean, personally, I'm feeling graph problems for the first time when you explained. I thought it's actually easy, but the implementation part is something where it it, it becomes hard or
Yeah,
actually
it
to
is.
apply.
Yeah, it is a matter of getting used to that notation. I bet you, like, you code the graph problems for one continuous week. Even if you have done a problem, you just try to repeat. And if the syntax that you get comfortable with BFS and DFS, you will say like this is a very easy category, because by mastering just 3 algorithms and one notation, you are able to solve the
Okay,
problems, right? So
okay,
BFS, DFS, and the graph notation, because notation becomes confusing. At times we feel like, hey, we are using the index or element in the array. That is where it becomes confusing,
yes,
right? Yeah, and this is something that can give you edge also. Not every company asks graph related questions. So I have not seen, apart from Amazon, Google, Facebook, asking graph related questions. But in
okay,
graph, there is another category of 2D matrix problems. I think interview bit has not put any pure graph problem. They have put all the problems on 2D array. This knight on a chessboard, word ladder is word problem. Then clone graph is something I can say it's a pure graph problem. Otherwise, if you see, most of their problems are uh, based on either the board. This is a board problem. This is a board problem. They are using 2D matrix as a graph.
yes,
So
yes,
so 2D matrix kind of problems are easy to deal with if you have solved some problems in that category,
okay,
right? And topological sort also, I don't think interview bit has any coverage on that. I don't see any problems mentioned here on that. Alien dictionary also probably not there. So there is a this slash problems where we can see alien dictionary, no.
no,
Dictionary, no. So this is a list of all the problems in case you need. This link they have not exposed anywhere, but at this link you can find all their problems that you have in their site. And
yes.
they have now 549 problems, and these are all new problems they are adding.
What is the URL? I mean, where did you actually went to get all the list?
I just I
Coding
just
problems.
know this
Okay,
URL. I just
okay,
know this URL, so I just typed it directly and got it.
okay.
Yeah, so it gives all the problems that they have. I mean, this is not with category. This is separate. I think they have similar way company-wise also somewhere. If you click a company name over here, you can see all Amazon problems
Yeah,
categorized. So this they put. Yeah. Now if you see these Amazon problems with various categories,
okay.
right?
Can you just ping? Okay, fine. I have that link. Okay.
Okay, I'll send you this link also. Ideally, what on that link, what I did, I just clicked the company name and it took
Yeah, I
me there.
understand. Understand.
So if we say here, we say Google interview questions, so you will get only Google. Yeah.
Okay.
Right.
Thank you, Sanjay. I'll start moving to. I'll jump into different levels and try to solve
Exactly.
problems.
Yeah. That way you can cover the ground much faster. So some problem that seem known to you, you can attack them and you will gain more confidence in
Yes.
interview.
Yes.
Right. Yeah.
Okay.
I'll put a
Okay.
message in the group also, telling others also to try the same.
Okay.
Yeah.
Okay. Sanjay, can you put the code so that actually first I'll try, but if in case I not stuck, we'll
Which
have
code?
something to the code which you have done for first positivity.
I sent that to you in your chat window. Or you want me to put in this note?
Sorry, I got it.
Yeah. Or I'll put in this also. So these links also that I sent you, I'm including. So these notes will be uploaded anyways.
Yeah.
So this was your missing integer, correct? So that is where we started, and then we went to the graph. So if it is available, you can refer to it later.
Yeah.
So this I'll upload before I forget. Yeah, so now you are feeling better, Srinivas, in problem solving.
Uh, what I feel is I mean, very slow in solving problems and better in the sense I think I'm learning every week, but still not so comfortable in thinking
In
optimistic
applying.
solutions. Yeah.
Okay, okay. Yeah,
Mentor pick,
gradually you will reach
mentor pick
there. Yeah, mentor
actually
pick.
in the first couple of weeks I've struggled, but then I've picked from the third week. Uh,
Mhm.
I mean, I was a little bit faster in solving problems in mentor pick, but now once I moved to interview bit, it's again the same. Maybe I think I'll
Okay,
practice more. I'll get comfortable.
okay. Sure, yeah, keep practicing. That's how you will become better. So if you struggle, like feel free to raise your doubts, raise your concerns, questions. So that way you learn even more.
Yeah. And Sandeep, actually, would the solutions for all the problems in mentor pick be shared?
No, we will not share all the problem solutions.
But after the end of the course, because I want to compare my solution with some other solutions or some other better approaches for each
Okay,
and every problem I've solved in mentor pick. So that's
okay.
what.
So sure, we will figure out a way. Yeah, if we can make some sort of guidance available or some sort of solutions available for that angle. Yeah.
At least a pseudocode or some approach of
Okay.
pseudocode where.
Approach pseudocode and describing the space and time complexity in which you can solve the problem in the best way. Right?
Yes. Yes.
Yeah, sure.
I mean, let's say, for example, there is a problem where somebody have used a map or I have used a set or somebody did not use a
Hmm.
map and still was able
Yeah,
to, uh, solve it. I'm not sure. Think maybe things like that will still help me to explore more on different options.
yeah, sure. Yes, Srinivas, we will take care of that task.
Okay.
Yeah.
Thanks. And
Okay, most welcome. Okay, then I'll close the session now.
yeah, yeah,
Yeah, bye, Srinivas.
yeah. Bye.